Hi, welcome to this video about statistics with RKWard and the package rkTeaching. In this video, we are going to talk about nonlinear regression, that is how to fit a nonlinear model to a dataset and how to use that model in order to predict. Well, let's go to the booklet of practices and go to chapter 5, nonlinear regression. Okay, here we are. Okay, let's start with exercise 1. In this exercise, I have a dataset with the evolution of a culture of bacteria. I want to know how bacteria depends on time, the evolution of the bacteria population. Well, first of all, we're going to create a new dataset and enter this data. So let's go to RKWard and create a new dataset. The name for this dataset is going to be bacteria. And we're going to define these two variables, time and bacteria, and type the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 25, 28, 47, 65, 86, 121, 190, 290, and 362. Okay, well, now in part B, it asks for the scatter plot. Remember that in our regression study, the first step must be always to plot the scatter plot, just to have an idea about how is the shape of the cloud of points, and that is how is the relation, the type of relation between these two variables. So in order to plot the scatter plot, I have to go to teaching charts scatter plot. So go to teaching charts and scatter plot. Here you have to select the variable that you want to represent in the y-axis, and what is the variable that you want to represent in the x-axis. Typically we're going to represent in the y-axis the dependent variable, and in the x-axis the independent one. In this case, bacteria is the dependent variable, so we're going to represent bacteria in the y-axis, and time is the independent variable that is going to be represented in the x-axis. And that's all. Submit. And here you have the scatter plot with the cloud of points of this sample. Well, according to the shape of this cloud of point, it thinks that the relation is not going to be linear, because obviously this is a curve, it's not a line. But I have doubts about if this shape corresponds to an exponential function, or it could be also a parabolic, quadratic function. Well, what to do when you have doubts about the type of model? Well, we're going to fit the models that are more appropriate, and then we're going to use the coefficient of determination in order to determine which one is the best. Okay. Fortunately, in RKWard and the package rkTeaching, we have a menu in order to compare different models, and we're going to use the coefficient of determination for that comparison. That's the next question. It asks for the quadratic and exponential models of bacteria on time. So in order to see which one is better, we are going to compare them. Teaching, regression, and models comparison. Here in this dialog, all you have to do is select the dependent variable in the model and the independent one, that is time. And here in the regression models tab, you have to select the models that you want to compare. So we're going to compare the quadratic, that is the parabolic, and the exponential, because I have doubts between these two. But it's a good idea also to select the linear model. Okay, then submit. Here we have the model comparison using the R square, that is the coefficient of determination. Well, as you can see, the best model is the exponential model with a coefficient of determination almost 1, but is almost the same that the quadratic model. So these two models fit very well. The fit is almost perfect. The fit of the linear model is not a bad model. It doesn't fit bad, but obviously it's not the best because the coefficient of determination is 0.87. Well, after looking at this table, now we can construct the best model, that is the exponential one. Okay, let's see how to construct the exponential model. So let's go to teaching, regression, and nonlinear regression. Here again, all you have to do is select the dependent variable, that is bacteria, and the independent one, that is time. And here in regression models tab, you have to select the model that you want to fit. In this case, the exponential one, that is the best. Then submit. Here we have the exponential regression model of bacteria on time. And here you have the equation. Okay, and the equation is the logarithm of bacteria. Remember that in order to fit an exponential model, usually we are going to convert the exponential model into a linear model, applying the logarithm to the dependent variable, in this case to bacteria. And for that reason, the dependent variable here is the logarithm of bacteria. And here you have the equation of a line. Well, according to this model, the coefficient of determination was 0.999, what I saw in the previous part. Okay, now we're going to plot the graph of this model on the scatter plot. So we're going to run again here the dialog for the scatter plot, and all you have to do is go to the fitted line tab and select the model that you want to plot, in this case the exponential one, and I get the scatter plot with the exponential model fitted. And as you can see, this is the curve for the exponential model. It fits almost perfectly the cloud of points. For that reason, I get so a coefficient of determination so high. Okay, now let's go to part E. It asks for how many bacteria there will be after 3 hours of the beginning of the culture and after 10 hours. So I'm gonna have to make a prediction. Remember that in RKWard, whenever you want to make a prediction, you need to fit, you need to save the model. Okay, so we're going to run again here in order to get the same dialog for the nonlinear model. And here, all we have to do is click in Save Model and give a name to the model. I'm going to give a name to this model, for instance, exponential bacteria on time. And that's all. Submit. I get exactly the same, but now the model is going to be saved in my workspace. As you can see here, I have the exponential model, and now we can use this model in order to predict. Well, let's make the prediction. Let's go to teaching, regression, and predictions. In this dialog, I have to select the model that I want to use to predict, that is the exponential model of bacteria on time, and then enter the value for the independent variable. And I want to predict for 3 hours and also for 10, so I can enter more than one value separated by commas. And that's all. Submit, and here I get the predictions. For 3 hours, 3.81, for 10 hours, 6.27. But be careful, because this is not the prediction of the number of bacteria, it's the prediction of the logarithm of bacteria. Because remember, in the model that I get, the dependent variable is not the bacteria, it's the logarithm of bacteria. So if you want to get the number of bacteria, you have to apply the exponential in order to cancel the logarithm, because the exponential is inverse of the logarithm. Well, you can do it with a calculator, or we can use the R console, and here we can apply the exponential function that is exp, and the values that you want for 3 hours is this. So I get approximately 45 bacteria after 3 hours, and for 10 I get 531 bacteria. Okay, so these are the predictions for 3 or 10 hours from the beginning of the culture. Okay. Okay, now in part F, it says give a prediction as reliable as possible of the time required to have 100 bacteria in the culture. Well, now again I want to predict, but in this case I want to predict the time. And for that reason, I cannot use this model, because this model is for predicting bacteria. Remember that whenever you want to make a prediction, the variable that you want to predict plays the role of the dependent variable. For that reason, I need to change the model. So we're going to teaching regressions, nonlinear regression. And now the dependent variable is going to be the time, and the independent variable the bacteria. But the problem now is that the model that I have to fit now is not the exponential, because if the relation between bacteria and time is exponential, the relation between time and bacteria is going to be the inverse. And the inverse of the exponential model is the logarithmic. So in this case, I have to select logarithmic. Okay? So be careful with this, especially when you are working with nonlinear models, because whenever you change the roles of the two variables, you have to change also the model, and you have to select the inverse. Well, now submit, and here I get the equation of the logarithmic model. As you can see here is the time, the dependent variable, and this is a line, but the independent variable in this line is no bacteria, it's the logarithm of bacteria. In order to convert a logarithmic model into a linear one, you have to apply the logarithm to the independent variable, like this. Well, the coefficient of determination is the same than before. Now we can save this model. I forgot to save the model. I'm going to save it. Just click Save Model and give a name to the model. Time on bacteria. Submit. And now we can use this model. Here we have the logarithmic model in order to predict. Okay, and I want to predict for 100 bacteria. So go to Teaching, Regression, and Predictions, and here select the model that I want to use. That is the logarithmic now, and the value for the independent variable, that is 100 bacteria. Okay, and that's all. Submit. And now I get the prediction of the time. This time you don't have to apply the exponential, because the dependent variable is time, directly time, so you don't need to transform this. I get directly the prediction for time, and it's 5.25 hours. That is more or less a quarter, 5 hours and a quarter. Okay. Well, this is exercise 1. Now let's move on to exercise 2. Here it says the dataset diet of the package RkTeaching contains data about a study about a diet. Okay. In this study I have 3 variables that are the diet, the number of days on diet, the weight loss during that time, whether he or she does physical exercise regularly. So I have 3 variables. First, we're going to load the dataset. This dataset is available in the RkTeaching package, so we can go to other environments and the RkTeaching package that appears here. and select this dataset that is diet. I think it's this one. We're going to make a copy to my workspace. Here we are, and you can open this dataset now, and as you can see, it contains 3 variables. The first is the number of days of diet, the weight loss after this number of days, and finally if this person does or does not do exercise. And finally, the third variable is exercise, if this person does or not exercise regularly. This is a factor, and it contains just 2 categories, no and yes. Okay. Well, part B asks for the scatter plot. Well, we're going to plot the scatter plot. Okay. I usually go to charts, scatter plot. Here we're going to represent the weight loss in the y-axis, the dependent variable, and in the x-axis the number of days of diet, and submit. Here we have. Well, according to this cloud of point, it's not clear which model to fit. So we're going to compare the different models. Okay, this is part C. Compute the regression model that explains better the relation between the weight loss and the days of diet. But first I need to know which is the best model, and for that we're going to compare the different models. Again, go to teaching, regression, and models comparison. Here the dependent variable is weight loss and the independent variable days. And since I have no idea about which is the best model, I'm going to mark all the models. Then submit, and here we have all the coefficient of determination. As you can see, the best model is the sigmoidal one with a coefficient of determination 0.66. That is not bad, but also is not a very good model. Okay, now we are going to compute this model, the sigmoidal model. Going teaching, regression, and nonlinear regression. Here, the dependent variable is the weight loss, the independent variable days. In regression models tab, I'm going to select sigmoidal, and that's all. Submit, and here we have. Here I get the equation of the sigmoidal model. Is this equation? It's pretty similar to the exponential one, because the dependent variable again is the logarithm of the weight loss. It's not the weight loss, it's the logarithm. And this is more or less like a line, except that days, the name of the independent variable is not multiplying, but dividing in a sigmoidal model. Okay, now we can plot this model on the scatter plot. So run again here in the scatter plot. And in the dialog for the scatter plot, just go to the fitted line tab and select sigmoidal. Submit. And here we get the plot of the sigmoidal model. That is the model that best fit this cloud of points. However, this is not a very good model because, as you can see, the points are not pretty close, are not very close to the line, to the curve, and the residuals are big. So the question here is, how can we improve this model? Well, in this case, we have another variable that is the exercise. Probably the weight loss is going to depend also on this variable, because it's not the same if you do exercise or not regularly. Okay, probably you're going to lose more weight if you do exercise than if not. So we're going to take into account this variable. And the idea is we're going to split the sample into groups, people who do exercise and people who don't, and let's see what happens if we fit two different models. Okay, this is part E, compute the regression model that best explains the relation between the weight loss and the days of diet for the group of people who don't do exercise regularly. Well, in order to see which is the best model, again, I need to compare the different models. And for that, we are going to go to Teaching, Regression, and Models Comparison. Here, the dependent variable, one more time, is the weight loss, and the dependent variable days. But now, as I want to split the sample into groups, people who do exercise and people who don't, we're going to select regression by groups. And here, in grouping variables, we're going to select the variable that we want to use in order to split the sample in groups. That is exercise. Okay? Remember that exercise has two categories: yes and no, people who do and people who don't do exercise. Then submit, and I get, sorry, I forgot to select all the models because I want to compare all the models. Here we are. And now, as you can see, you have two models comparison, one for people who don't do exercise and one for people who do exercise. For people who don't do exercise, the best model again is the sigmoidal model, but we have improved a little bit the model because in the previous one, if you remember, the coefficient of determination was 0.66, and now for people who don't do exercise, the coefficient of determination of this model is 0.74. That is better. For people who do exercise, we have improved even more the fit of the model, because now the best model is the inverse, and the coefficient of determination for this model is 0.84. And this is a good model in order to predict now. Well, as you can see, just splitting the sample into groups, we can improve the models in order to make predictions. Okay. Now we are going to construct the best models for both groups. That is, for people who don't do exercise is the sigmoidal. For people who do exercise is the inverse. Okay, well, let's start with people who don't do exercise. Okay, now go to Teaching, Regression, Nonlinear Regression. Here select the dependent variable, that is weight loss, the independent variable days. And now we have two options. First, we can select regression by groups and use the variable exercise to split the sample. And finally, in the regression models tab, select the model that I want, that is the sigmoidal, and then submit. And here we have two models, one for people who don't do exercise, one for people who do exercise. But remember that the sigmoidal model was the best for people who don't do exercise, so you can forget about this model. Okay, don't pay attention to this. This is the model that I want. And the other option, okay, if you don't want to get two models, just the model that you are interested in this case, instead of regression by groups, we can apply a filter. And the filter is going to be exercise double equal quotes no. Okay, remember how to apply a filter. You have to write exactly the same, the name of the variables and the name of the categories. The regression model must be the sigmoidal, and since as I want to use this model to predict, I'm going to save it. Just click Save Model, give a name to the model, sigmoidal, weight on days. Apply, and here I get just one model, just one, but this model is the same that the one that I got here, are the same, okay, as you can see. And now I have a model in my workspace, a sigmoidal model, okay. And now we're going to fit the model for people who do exercise. All you have to do is run again. Here we're going to change the model, because remember that for people who do exercise, the best model was the inverse, not the sigmoidal. And here in the filter, now instead of exercise equals no, I have to write exercise, sorry, yes, double equal yes. And we are going to give a different name to this model. Instead of sigmoidal, I'm going to use inverse. Okay. And this is the model that I get now. Okay, this is the inverse model. And finally, the last part of the exercise is use the previous models to predict the weight loss for a person after 40 days and after 300 days of diet for people who do exercise and people who don't. Okay, well, for people who do, I have to use the inverse, this one, and for people who don't, I have to use the sigmoidal. Okay, so all I have to do is go to teaching, regression and predictions, and here first I'm going to predict for people who don't do exercise, that is the sigmoidal model, and I want to predict for 40 days and 300 days. Then submit, and here I get the predictions. But remember that in this model, in the sigmoidal, the dependent variable is not the weight loss, it's the logarithm of weight loss. Okay, so in order to get the weight loss, I have to cancel the logarithm, I have to apply the exponential. Open the R console and just apply the exponential to the first prediction, that is this. So I get approximately 9.5 kilograms. After 300 days, I get the prediction is going to be approximately 16.25 kilograms. These are the predictions for people who don't do exercise. And now we're going to repeat the same but for people who do exercise. In this case, I have to use the inverse model. Okay, so I'm going to run again. And here just change the model. Instead of the sigmoidal, I'm going to use the inverse. And submit. And here we have, this is the prediction using the inverse models. And now I don't need to apply the exponential because in this model, in the inverse model, I get directly the weight loss. So for people who do exercise after 40 days, the weight loss is going to be approximately 15.18. That is greater than this one, obviously, because people who do exercise lose more weight than people who don't do exercise. And for 300 days, the prediction is going to be 20, approximately. Okay, and that's all. In this practice, we've seen how to fit a nonlinear model, how to compare the different models in order to take the best, and how to use the models in order to predict. I propose you to try the proposed exercises. That's all. Bye.